What's up, space fans? Today I've got some absolutely mind-blowing news that's going to change everything you thought you knew about rocket design. SpaceX just announced they're doing something that sounds completely insane on paper, but when you dig into the engineering, it's actually pure genius. They're removing one of the 4 grid fins from their super heavy booster. Yes, you heard that correctly. They're going from 4 fins to 3, and before you start thinking Elon Musk has completely lost his mind, stick with me because the engineering behind this decision is absolutely fascinating. We're talking about a design change that could revolutionize how we think about rocket recovery systems. This isn't just tweaking something that already works. This is reimagining the entire approach from the ground up. So grab your favorite space-themed drink, hit that notification bell, and let's dive into one of the most intriguing engineering puzzles in modern spaceflight. Here's what we know. The next generation Super Heavy booster is getting a complete makeover, and the most eye-catching change is this 3-fin configuration. But here's where it gets really wild. These 3 fins won't even be arranged symmetrically. SpaceX is going with what engineers call a 90-90-180 degree configuration. That's fancy talk for a completely asymmetrical pattern. When I first heard this, my brain immediately went to, wait, that can't possibly work. Right, but remember, this is SpaceX we're talking about. These are the same people who said they were going to land rockets on drone ships in the middle of the ocean. And everyone thought they were crazy. These are the same people who said they were going to catch a 20-story tall rocket booster with giant mechanical arms. And everyone said that was impossible. Yet here we are, watching super heavy boosters get caught by Mechazilla like it's no big deal. So when SpaceX says they're going asymmetrical with their grid fins, maybe we should pay attention. The new booster is going to be absolutely massive. We're talking 72.3 meters tall. That's about the height of a 20-story building. When you stack it with the next generation Starship, the entire vehicle reaches 124.4 meters. That's taller than the Statue of Liberty, pedestal included. Okay, so let's talk about why this actually makes sense. At first glance, removing a control surface seems like the worst possible idea. These grid fins are literally what keep the booster stable during that incredible belly flop maneuver we've all seen in those viral videos. But here's where SpaceX's thinking gets really clever. Let's start with the flip maneuver. When that super heavy booster comes screaming back through the atmosphere, it has to perform this absolutely mind-blowing controlled rotation. Picture a 50-story building doing a graceful pirouette in midair. That's essentially what's happening. During Flight 9, SpaceX did something called an active flip by channeling engine thrust through a deliberate hole in the hot staging ring. Now, by removing one grid fin, they're creating a shift in the booster's mass distribution and aerodynamics. This actually makes the flip maneuver more efficient. The booster needs less energy to rotate, making the whole process smoother and more controlled. But wait, there's more. Once the booster completes its flip, this asymmetrical grid fin placement does something that sounds completely backwards, but is absolutely brilliant. It generates symmetrical lift. I know that sounds impossible, but the physics actually work out beautifully. This symmetrical lift helps reduce drag during re-entry, which means more precise control over the descent path. Less drag equals less fuel needed for trajectory corrections, which equals better efficiency overall. And in the rocket business, efficiency is everything. There's another benefit that most people aren't talking about. SpaceX has been experimenting with steeper landing approaches, basically coming in at a higher angle of attack. This can reduce landing loads and improve recovery precision. With this new fin configuration, they can maintain control even at these steeper angles. And here's something practical that's easy to overlook. Fewer grid fins mean more open space around the booster's body. This could actually make it easier for those massive Mechazilla arms to align and catch the booster. Less clutter means cleaner catches, which means more reliable recovery operations. Now let's talk numbers, because this is where things get really interesting. Each grid fin on the super heavy booster weighs about 3 tons and measures roughly 3 meters by 7 meters. To put that in perspective, that's nearly 20 times heavier than a Falcon 9 grid fin. These things are absolute monsters. By eliminating just one of these massive structures, SpaceX reduces the booster's overall mass significantly. And in the rocket business, every single kilogram matters. Lower mass means less strain on the engines, potentially higher payload capacity, and more efficient fuel usage. But the real genius is in the long-term cost savings. Unlike Falcon 9, which uses expensive titanium fins, Super Heavy uses stainless steel grid fins. While they're heavier, stainless steel is much cheaper and more heat-resistant. SpaceX reportedly spends just $10,000 for 3 tons of 304 stainless steel. Now, eliminating one fin might not seem like a huge cost-cutting measure for a single rocket, but when you're planning to build thousands of Starships, and that's exactly what SpaceX intends to do, those savings add up incredibly fast. We're talking about millions of dollars in materials alone, plus reduced manufacturing time, easier refurbishment, and fewer parts to inspect or replace. This perfectly embodies SpaceX's broader philosophy of simplification. Every Starship system is being refined not just for performance, but for cost, speed, and scalability. It's this kind of thinking that could make space travel as routine as commercial aviation. So when are we actually going to see this 3-fin wonder in action? The first booster to debut this new layout will likely be B-18. Recent upgrades and structural similarities with test components suggest it's part of the next-generation Super Heavy family. B-18 was stacked back in May, and once its forward section is completed, we should get our first real look at this new configuration. If everything stays on schedule, and that's always a big if in the rocket business, we could see it fly later this year. Of course, that timeline depends on resolving any issues from recent testing setbacks. The production benefits of this design change are absolutely massive. Fewer fins mean faster production lines, easier quality control, and streamlined assembly processes. When you're trying to build rockets at airplane-like production rates, every simplification matters enormously. This isn't just about making one rocket better. This is about making thousands of rockets possible. SpaceX isn't just building a launch system. They're building a manufacturing revolution. They're thinking about how to produce these vehicles at scale, which is something the aerospace industry has never really had to consider before. But the grid fin changes are just the tip of the iceberg. The next generation Super Heavy is getting a complete system overhaul, and some of these upgrades are even more impressive than the fin redesign. First, let's talk about fin positioning. The 3 remaining fins aren't just fewer in number, they're also mounted lower on the booster body. Flight data showed that the current fin placement puts them dangerously close to the intense exhaust from Starship's engines during hot staging. This caused minor melting and thermal wear that required extra inspection and refurbishment between flights. By moving the fins lower, SpaceX is protecting them from unnecessary heat exposure. Less heat damage means less refurbishment time, which means faster turnaround between flights. And rapid turnaround is absolutely crucial for SpaceX's vision of airline-like space operations. The hot staging system is getting a major upgrade too. The hot staging ring, that's the structure managing the transition from booster to upper stage, is no longer disposable, taking inspiration from the Soviet N-1 rocket. This updated ring is now a permanent, recoverable component designed for reuse. The new ring is longer and equipped with significantly enlarged exhaust vents. These aren't just cosmetic changes. They're crucial for safely managing the massive forces and intense heat during engine ignition and stage separation. The enlarged vents help prevent damage to sensitive areas like those relocated grid fins. Now, let's talk about the star of the show, the Raptor 3 engine. Externally, it stands out with a sleek black finish, but the real improvements are internal. Many small, delicate components that were once externally mounted have been removed or fully integrated into the engine body. This reduces failure points and makes the system more robust. The Raptor 3 produces 280 tons of thrust at sea level and 306 tons in vacuum, When you multiply that across all 33 engines on the Super Heavy booster, total liftoff thrust could exceed 9,000 tons. That puts SpaceX within striking distance of their goal of 10,000 tons of thrust. 10,000 tons would make Starship the most powerful launch system ever developed. We're talking about a rocket more powerful than the legendary Saturn V that took humans to the moon. Now, let's be realistic here. While these upgrades are incredibly impressive, SpaceX still faces serious challenges. The Super Heavy booster is maturing nicely. It's already demonstrated successful landings with those spectacular Mechazilla catches, but it still needs to prove long-term stability and consistent engine performance as launch cadence increases. The bigger challenge is actually the Starship upper stage. Despite major advances, it suffered repeated setbacks this year. We've seen thermal protection failures, engine underperformance, and most recently, the complete loss of Vehicle S-36. SpaceX needs to address thermal protection systems, validate orbital engine burns, reinforce structural elements, and refine recovery strategies in the near term. Testing will ramp up with B-18 and the first version 3 prototypes. These trials will showcase the three-fin design, the streamlined hot staging ring, and those powerful new Raptor engines. The journey to full reusability is never easy, but each breakthrough brings us closer to making space travel routine and affordable. And that's really what this is all about. Not just building better rockets, but opening up space for everyone. So there you have it. SpaceX's bold move to drop a grid fin isn't just about weight savings or cost reduction. Though those benefits are huge, it's about reimagining how we design rockets from the ground up. It's about questioning every assumption and finding elegant solutions to complex problems. This three-fin design represents everything that makes SpaceX special: bold thinking, iterative improvement, and an unwavering focus on making life multiplanetary. Whether this particular innovation succeeds or fails, it shows that SpaceX is still pushing boundaries and challenging conventional wisdom. What do you think about this design change? Are you excited to see how it performs? Or do you think SpaceX is taking unnecessary risks? Drop your thoughts in the comments below. I love hearing from fellow space enthusiasts. If you enjoyed this deep dive into Starship's evolution, smash that like button and subscribe for more space exploration content. There's never a dull moment in the world of SpaceX, and I'll be here to break down every exciting development as we continue this incredible journey to the stars. Until next time, keep looking up and keep dreaming big about humanity's future among the stars. Thanks for watching, and I'll see you in the next video.